Okay, so today we're gonna do a couple more things with angles inside of circles. So we've already talked about central, right? Central. See if I can draw on this. Central, your vertex is on the center, and we did central same. So if it was 50, the central angle is 50. We also did inscribe. This is very angry with me. Let me try and scroll this back up. Inscribed was on the circle, right? On the circle, and this was Pac-Man. We said Pac-Man was a messy eater, so only half made it in. So if it was a 100-degree arc, the angle would be 50. So we talked about those two. Now, what do you do for all the other different types of angles? So you could have angles just hanging out somewhere inside. Notice they're not on the center point, but they're just kind of hanging out inside somewhere. Or you could have angles on the outside of your circle. So today we're going to talk about inside and outside. Again, when I say inside, I'm not talking about central angles. So central, the vertex is on the center. Here, if you notice, here's my vertex. It's just hanging out somewhere inside the circle. Right? Here, my vertex is outside the circle. So when I say inside and outside, that's what I'm talking about. Your vertex is inside the circle. Your vertex is outside the circle. And you do have two little formulas. So for if it's inside, which these angles right here, these angles are inside. So if you wanted to find these two angles, you would add the arcs, so A plus B, and you would put half in each. You would add your arcs and put half in each. Same concept here. A plus B, whatever those arcs are, and you put half in each. So when it's inside, you just add those arcs, cut them in half. Right? Put half in each angle. If it's outside, you subtract your arcs. So you would say B minus L, and B and L are just big arc, little arc. But subtract B minus L, and then put half outside. So subtract, put half outside. The way I kind of remember is when it's inside, it kind of looks like a plus sign. If you tilt your head, squint your eyes, it might look like a plus sign. But that's how I remember to add. And then outside kind of looks like a minus sign, kind of, sort of, maybe. And that's when you subtract and cut it in half. So again, still the same concept. Subtract B minus L, cut it in half. B minus L, cut it in half. So again, if that vertex is outside the circle. Let's try some examples. Let me zoom in, actually. Here we go. All right, so example 1. Again, I see that vertex is inside the circle, and it's not on the center. So I say, okay, I'm going to add my arcs, 205 plus 37, and I'm going to cut it in half. And then you just let your calculator do the work. So you would type in your calculator 205 plus 37, get a number, which is 242. I'm going to go ahead and write that, 242. And then we're going to cut that in half. So you got 121. And understand what that's representing. That's this angle right here, and this angle right here are each 121 degrees. All right, same concept here. We got an angle hanging out. The vertex is somewhere inside the circle. So again, you add your arcs, 58 plus 102, and you cut it in half. So we do 58 plus 102 is 160. Half of that would be 80. So you know that this angle, which is x, is 80 degrees, and this angle is 80 degrees. And that was our answer, so we're done. Now on the next one, on example 3, you kind of have to think backwards. You have to think backwards a little bit. So we see that this angle right here is 64 degrees. Well, we know that we add our arcs, and we cut it in half to get these angles. So x plus 118, and we cut it in half, and I'm telling you I got 64. Right? Same concept here, 58 plus 102, and we got 80. Right? We cut it in half and we got 80. X plus 118, we cut it in half and got 64. So work backwards. We're going to double both sides. Multiply by 2. So that'll cancel. We got x plus 118 equals 64 times 2 is 128. And then you're going to subtract 118 from both sides, and you get 10. So you know x is 10. And you can always go back and check, right? Plug in your answer and see if it works. 118 plus 10 is 128. Cut it in half. You should get 64. If not, you messed up. So you can always go back and check your answers and make sure that they work. Now on examples 1 through 3 over here, notice here my vertex is outside. So when it's outside, I think subtraction. So big arc minus little arc, cut it in half. 177 minus 53, cut it in half. So first we're going to do 177 minus 53, and we're going to get 124. I'm going to write it down here. I'm running out of room here. And when we cut it in half, we get 62 degrees. So we know this angle right here, x, is 62 degrees. Now the next one, again, see I'm outside, but I don't know what the big arc is. So you might have to do a little math to find out what the big arc is. You know his circle is 360. And if we subtract out 178 and 36, we'll be left with this arc right here. So 360 minus 178 and 36, I get 146, which is that arc. And now you can do the problem just like we did here. Big arc minus little arc, cut it in half. So that was 146. So we have 146 minus 36, and then we're going to cut it in half. So you do 146 minus 36, and you get 110, and you cut that in half, and you get 55 degrees. All right, next one, kind of the same example, right? Again, we're outside. I don't know what this is, right? I don't know what my big arc is. Same concept. You know there's 360 degrees in a circle. Subtract out the 82 you already know. So you got 360 minus 82, which tells me this is 278. So you know this arc is 278. Now you can apply your theorem. Big arc minus little arc, cut it in half. 278 minus 82, and we want half of that. So 278 minus 82 is 196. Cut it in half, and you get 98. Sorry, I was running out of room a little bit there. But you get that this angle outside is 98 degrees. So angles inside, add your arcs, chop it in half. Angles outside, subtract your arcs, chop it in half. Let's try a couple more examples, and then I'll set you free to finish the work. All right, what do we got? We're missing the little arc, right? We see that it's outside, so we think subtract and cut it in half, but we're missing that little arc. So we're going to take our total 360, right? Total 360. We're going to subtract out 102 and 205. So 360 minus 102 and 205 gets me 53. So you know that this arc is 53 degrees. And now you can subtract and cut in half. So 205 big arc minus little arc, chop it in half. So 205 minus 53 is 152, and then divide by 2, I get 76. And there's your angle, 76 degrees. Question 2, again, I see inside, I think addition. So add my arcs, 196 plus 62, cut it in half. So 196 plus 62 gets me 258, and we're going to divide by 2, and we get 129. So you know this angle right here is 129, and that angle is 129 if you needed it, but we don't. Again, on this one I see outside, so I think subtract. I don't know what the little arc is. So again, total 360. Subtract out the one you already know, 228. Sorry about that. You get 132. So this right here is 132. Now you have outside and you can subtract, cut in half. So 228 minus 132, cut it in half. So 228 minus 132 is 96, and half of that is 48. So you get that this angle is 48 degrees. And last but not least, straightforward, it's outside. I have both arcs, so we're going to subtract. And we're going to cut it in half. So 102 minus 55 gets me 47. And we're going to cut that in half, and we get 23.5. Oops. Degrees, sorry. And that's it. All right, so go ahead and get the worksheet done. Make sure you show all of your work. I know there's not much work. If you do the 360s, I want to see them. If you cut it in half, I want to see it. But make sure just as much work as I showed on here, I expect to see on your homework as well. So identify which type you're dealing with. Is it inside, right, or is it outside? And then go from there. Inside, add your arcs, chop it in half. Outside, subtract your arcs, cut it in half. All right, bye guys, get your work done.